Hi there. Today we're going to talk about the layers of the Earth. Now I want you to remember that you can pause this at any point if you need more time to write something down or draw something, or rewind if you need more clarification on any portions of this. As you can see, the Earth is broken up into multiple layers, and we're going to talk about each one, what it's made of, and some of the properties that it has. So let's start with the Earth and look at the layers it's divided into. We're going to talk about four distinct layers, starting from the inside, working out. Start with the inner core in the very center, followed by the outer core, the mantle, and the crust. Now I know it's going to be difficult for you to try and draw the Earth in this 3D kind of picture. So let me suggest that instead you focus just on a two-dimensional picture, something more like this. Again, if you need to pause to do your picture, go right ahead. So again, for the rest of this presentation, we're going to look at it like this so you can see the crust, the mantle, the outer core, and the inner core. I just want to give you a few different perspectives on how the Earth is broken up, that all of them show the four distinct layers. So we're going to work our way again from the inside out, and we're going to focus again beginning on the inner core. The first thing to know is it's mostly made of iron, and it is solid. Now, the interesting thing about the inner core is the fact that it is extremely, extremely dense. If you had an entire huge ball of iron, it would be super heavy, and indeed the inner core is. It's about 800 miles thick, which, if we're going to use metric, is 1,200 kilometers. And it is estimated to be about 9,000 degrees Fahrenheit. Now, iron at 9,000 degrees Fahrenheit should be a liquid, but because it's under so much pressure from the weight of the entire planet pushing down on it, it actually keeps it as a solid. If we move out to the outer core, it is also made mostly of iron, but also nickel. And it's important to see that distinction. The metal here is easily magnetized. And in this case, it's still very hot, but it doesn't have as much pressure. And so it's actually a liquid, not a solid. And that's important because it moves. And we believe that that movement of this magnetized metal is actually what gives the Earth its magnetic field, which we'll talk about a lot more later in the course. Now, it is thicker than the inner core. It's 1,400 miles, which is about half the distance of the United States. So it's very thick. And it's a little cooler, somewhere between 4,000 to 9,000 degrees Fahrenheit. The farther from the center we get, the cooler the Earth is going to get. Our next section is the mantle, and this is the thickest section of the Earth, and it's actually made of softened rock. Now, I want to dispel a little misconception here. The mantle is not actually lava. There are portions of it that are magma, that are molten liquid rock. But the majority of the mantle is actually what we call a plastic. I want you to think of kind of more like a jello or or clay, where it's movable and shapeable and can move from one place to another, but it's not a liquid. Um, it's like a hot, chunky, very, very viscous material. If you've ever seen the city workers come down your street and put a new asphalt street in, and they pour it on, it's that very chunky black. It's not liquid, but it's not quite a solid either. So that's what we mean by a plastic. Um, like I said, it's the thickest layer of the Earth. It's about 1,800 miles thick. And again, as we get farther away from that center, it is cooling off more and more and more. It's between 1,600 and 4,000 degrees Fahrenheit. Now, we have our four sections of the Earth, the inner core, outer core, mantle, and crust. But before we get to the crust, I want to break the mantle down a little more. We can actually break it up into two different layers. And you can see over here, we have both the upper mantle, which is a fairly thin part of the mantle, and then the lower mantle. And this distinction is important. The lower mantle is basically what I've been talking about so far, this very plastic, um, soft rock type of situation. The upper mantle, on the other hand, is actually broken into two pieces. And if we look here on the left, you can see them. The first is the lithosphere, which is the very top part of the mantle right here, along with the crust on top. And it's only about 1,000 kilometers thick. So we're talking 70 miles or so. And it is rigid and solid. The entire thing is basically rock. The next part of the upper mantle is called the asthenosphere. We can see right here, and it is the upper mantle that lies right below the lithosphere. And this is the part when we think of magma inside the earth, this is what we're thinking about. This is a soft, weak layer. It's easily deformed. It goes about 660 kilometers, or about 500 miles down, and it is the classic magma you think of. So when lava comes out of the earth through a volcano, it is coming from the asthenosphere. Okay, that brings us to the crust, and so let's move on up the road there. The crust is obviously where you live. It is made of rock, and it is the least dense layer. When we get into our unit on astronomy and we're talking about the formation of the Earth, we'll talk about how these densities have affected how the Earth formed. There are actually, again, two types of crust. There is the continental crust right here, the portion where the continents are on, and then the oceanic crust right here, where the oceans are on top of. So let's talk about them separately. The oceanic crust, again, it's under the oceans. It's actually made of a rock called basalt, and it is very dense, but it's very thin. It's only 3 to 5 miles thick. So you may think, wow, the crust isn't very thick there. Yes, but it has the entire ocean on top of it too. So it's not like lava's just going to jump out of there. The continental crust, however, is again the crust that's under the continents, and it's made mostly of granite. It's also far less dense, and it can be anywhere from 25 to 37 miles thick. So those are the 4 layers of the Earth. And the question might be, how do we know? That's a great question. We, as humans, have only ever gone through a small portion of the crust. We've never dug deeper than that. No human's ever been in through the lithosphere into the asthenosphere. First of all, we don't have the equipment to survive that kind of heat from the magma in there. But we just have never done it. We don't even have the equipment to handle the pressure that would be under going that deep inside the earth. So how do we know? There is a simple answer, but that simple answer is actually very, very complicated. So the simple answer is seismology. It's the study of earthquake waves. Now, later in the course, we're going to have a whole unit on earthquakes, and we'll study their waves in depth. But I do want to just cover with you a little bit how we know. When the energy is released from a wave, from an earthquake, the waves of the motion, it's kind of like an effect of when a pebble is tossed into a pond. They're set up, but not in the water, but on the entire earth. And so we have a situation like this where we have waves emanating from where the earthquake started all the way through the earth, both on the surface, which we feel, but also deep, deep, deep down, and actually through the earth. And there's not just one type of wave that comes from an earthquake, which we will learn in the future. There's multiple kinds. And so we look at how fast the earthquake waves travel through the rocks, which we call seismic velocity. And that velocity depends on the composition of the material and the pressure it's under. So we can use the behavior of the seismic waves, of the earthquake waves, to tell us about the interior of the earth. We have a situation like this. We have an epicenter here up at the top, and we get our waves that spread along the surface. We also have waves that come through the center of the earth, and we can calculate where all these are, how fast it gets there. And some of these waves, once they hit the outer core, stop. They can't actually even go through a liquid, so they just stop. Others actually bend, and once they come out the other side, they bend again. So we can look and chart these waves, knowing when the earthquake happened and when those earthquake waves reach other points on the surface of the earth in order to make calculations to see what exactly is going on inside the earth. And that's been able to tell us not only what the earth is made of, but whether it's a liquid or a solid or a plastic. I hope you've enjoyed learning about the layers of the earth, and I'll see you in class.